Hi, and welcome to the Binary Space Fusion 360 course. In this, our first course, we will be designing an Arduino UNO enclosure that you can easily 3D print for yourself. To start with, let's have a look at the dimension drawings for an Arduino UNO. We will be using this to create a base reference around which to design our enclosure. If we have a look at these dimensions, you can see at the bottom left, there's our Arduino UNO. It is 53.3 millimeters high and 68.6 millimeters wide. We will not be bothering to create all the little corners and cutouts because we are simply interested in the shape of this Arduino UNO. So let's switch over to our Fusion 360 environment. I am going to assume some familiarity with Fusion 360. So to get started, let's create a sketch. Sketches are the basis for all objects in Fusion 360. So let's create one right over there. And then I am going to be using a center point rectangle. The reason I use center point rectangle as a quick tip is I like to create all of my sketches around the origin point of your sketches of the object. It makes for simpler symmetry and working with assemblies in the future when we have multiple components. So let's go ahead and do a center point rectangle. Then we switch back to our drawing quickly. The height was 53.3 and the width was 68.6. This one was 53.3, 68.6. Pressing tab after you've typed in the dimension will lock that dimension in place as evident by the little lock icon next to it. Now press enter. We will now have our fully dimensioned rectangle. Quick tip number 2, get that to fit nicely. You can simply double click your middle mouse button and it will make sure to bring the entire sketch viewport. Now this will be the outline of an Arduino board, but let's face it, manufacturing isn't perfect, so we can't create an enclosure that will fit perfectly around an Arduino UNO. What if it's 0.1 millimeters longer than what it should be? So we are going to create an offset around this shape to give us some space. Under the modify option, under the sketch option, sorry, is the offset command. It's got a shortcut key of O. Future reference. Click the shape of the rectangle and it will allow you to create an offset either inside or outside of this object. I'm going to say I want to create a 1 millimeter gap around my board for the inside of my enclosure. Hit OK, and now we should have a second rectangle in place. Now, as this rectangle, the inside rectangle, plays no part in our actual geometry, simply there for reference, I'm going to convert it into construction lines. Construction lines are like these dashed lines that are here present on the sketch already. They are there simply for construction purposes, i.e. they don't play any part in your actual geometry. They are simply there to provide reference points for the rest of your sketch. To do that, you select your line and then under your contextual options you have a normal construction. This toggles the line between a normal line and a construction line, or one could use the shortcut key X. So once you convert it, you should see it should also turn into a dashed line. I'm going to do that for the other 3 edges of our inside rectangle. And now we have our rectangle giving us our profile for this enclosures inside. I'm going to stop this sketch here and return to 3D view. The view cube up here always tells us in what view we currently are. It gives us options to jump to different views. Also, if you use shift, little mouse button, hold it in and drag, rotate around your design. In this case, I like working in the home view, which is a 3D view of your current design. And now we are going to create this rectangle, get a cube by extruding it. To create, there's an extrude option, shortcut key E. Use that to turn this into a solid object. So first of all, it asks us to select our sketch geometry, which is our rectangle, and then we can use this little arrow to drag it out the size we want it to be, or you could also type in the height that you want. In this case, we want this to be 22 millimeters high. Why 22? It gives us enough space for an Arduino and some leg room on the top and bottom width. Press on the home button again, it should bring our cube into view. Next, this may seem very counterintuitive because all that we have now is a solid cube, and at that we create the cube around the inside diameters of what we want our enclosure to be. Seems very counterintuitive to design this way, but what we have actually done is we are going to use a trick in Fusion 360 specifically for situations like this. This block represents the negative space we want to create inside of our enclosure. So to do that, we want to create a shell around this space. Use the modify shell command. What shell does is it removes material from a part interior, creating a hollow cavity with walls of a specified thickness. What we are going to use it for is a trick, though, where we are going to use this entire body. So instead of selecting each one of the faces manually, we are going to extend our bodies here. We're going to say, I want to create this body, and then our direction that we are going to use is we are going to say outside. What outside means is we are going to create a shell around the outside of this body instead of shelling this body itself. And then I am going to make the thickness of this body, of this shell, 1.6 millimeters. Okay. And now it looks like we have simply created a slightly larger cube. How do we know that it is actually a hollow inside? We are going to use one of the features from Fusion 360, sectional analysis. Under our inspect menu, see there is an option called section analysis. Section analysis allows you to create cutaway views of your 3D geometry. I'm going to select this face. Then as we drag this backwards, see we have actually created a hollow block. We don't need to leave the sectional analysis in place. It is purely there for viewing purposes to make sure that our command has actually succeeded. So in this case, I am going to cancel it, and we are going to work further from here. Next up, what I want to do is I want to create rounded corners for my enclosure. Simply, I do not like these sharp edges, and I do not think that it will be very aesthetically pleasing. So we will go and modify our object once again, and then you'll see there's a command called fillet. Fillet rounds an edge. It is a very often used command, so it also has its shortcut key F, and then it asks us which edges do we wish to fillet. In my case, I want to do this upright edge, this upright edge, rotate around this way, this upright edge, and this upright edge, and I want to fillet by 2 millimeters. 2 millimeters creates a 2 millimeter radius edge. Once you're happy, go ahead and hit OK. And if we look at our object, we neatly rounded edges now. Now, this enclosure is pretty useless to us right now at the moment because it's a solid block, solid box. You can't get anything inside of it. Let's fix that. We want to slice this box exactly in half so that we have a top half and a bottom. To do that, find a midpoint between the bottom and the top of this box. We are going to create what is called a mid-plane. Under your construction options, select mid-plane. It creates a construction plane at the midpoint between faces or workplanes. We want to create the mid-plane between the top of this box and the bottom of this box, and you'll see our workplane. Now what we want to do is we want to actually split this body along this workplane. Once again, we go to the modify option, and there's an option called split body. Split body allows you to split a physical body into more along any plane or profile that you can select. In our case, we want to split this body, and as our splitting tool, we want to use this midplane. You should get a red circle indicating how it's going to cut. If we hit OK, you should see body 1 and body 2 have become 2 bodies. You can now turn off this construction plane, and then have a look. You can switch off top of this lid, the lid part, or we can switch off the base part and have a look inside of our lid. For now, we are only really interested in the bottom part of our box because we still have to create our mounting pins. So for the mounting posts, we need to follow the outline of the holes on our dimension drawing. So let's get started by saying we need to create another drawing on the inside of our bottom face of our enclosure. Jumping back into Fusion 360, we'll go to create a sketch, and this time instead of creating it on a plane, we will create it directly on the inside face of our enclosure. Just right click, middle click and drag a bit to get it back into view. Now if you will remember correctly, our inside of our box is 1 millimeter bigger than what the dimension drawing was of our Arduino. So we could go ahead and increase all of our dimensions by 1 millimeter, etc., 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 to get it to the correct positions, but that is going to be a lot of keeping things in mind, especially if we later want to make changes, etc., etc., etc. One of the nice things about Fusion 360 is we can project things from other geometry, other sketches, etc. into the sketch that we're going to do to base things off of that. So for this, we're going to go to Sketch and Project Include, Project, or shortcut key is P. And then we can go and look at our sketches, and we'll activate sketch 1, which was our original sketch that we made for the inside of the Arduino. And now we can go and say, I want to project this outline of the Arduino that we created to this drawing. Say OK. The lines will be projected, as can be seen by the purple lines that are present, and now we can switch off that sketch again. And there we have our original Arduino outline that we created. If we go back to our drawing now, we can see there's 4 holes, and if we look at the notes, we can see that they say all the Arduino mounting holes are 3.2 millimeters in diameter. We're not going to create our mounting pins to be 3.2 millimeters big, because that would be way too big and they would be way too tight while we try to get our Arduino to fit over there. So instead, we're going to make them a little bit smaller. We're going to make them 2.8 millimeters. Also, have a look at the pattern that they are in. We are going to just put down our holes or our pins, and then we'll worry about the exact positioning after we've done that. Let's jump back into our Fusion 360, and then we're going to go circle, center, circle, center, diameter, circle, shortcut key C, which I'm going to be using just now, and we can say, okay, we have circle here, and we are going to make it 2.8 millimeters in diameter. Then we can continue and say there's going to be another one up here somewhere. I'm not going to give it an exact dimension. Instead, I'm just going to put it down. Create another one over here somewhere, and another one over here somewhere. Instead of giving them all dimensions and making them all 2.8 millimeters, to make sure they always stay the same for in case we come and change one, we will simply use the sketch constraint equals. What we do is we go and we say select this circle and that circle, and they will be made that circle and that circle, they will be made equal, that circle and that circle. And now we have 4 circles that will always remain the same size if we should resize the size of our pins. Let's head back to our sketch, and we can see that the 2 holes or pins on the right hand side will be aligned directly underneath of one another. Let's go back into Fusion 360 and make sure that we have a similar constraint here. So what we will do is we will select that point, hold shift and select that point, and now we're going to select here that they should be horizontal or vertical from one another. This is where it is important to get your basic shape correct, because if you don't get your basic shape correct, then it might have moved those holes to be in horizontally from each other instead of vertically. So it helps to make your sketch seem at least relatively the same than what you are aiming for at the end of the day, so that Fusion 360 can automatically determine from your positions when you select something like horizontal, vertical, that is in fact what you were trying to achieve. And that is pretty much the only constraints that we can apply based on our drawing. Now we need to start placing our dimensions. I am going to start from the left hand side because all of the drawings dimensions are specified from the left hand side, and I'm going to start with the bottom left hole, as that one is specified as the furthest back from all of the holes. Let's go back into our Fusion 360, and it is specified to be 14 millimeters from the left edge. Press D for diameter. Select the center pin or the center of your hole and select this line, which is the one that we projected in. And now I'm just going to zoom out a bit. Going to say that that is 14 millimeters. Our next dimension specifies that that next hole is 1.3 millimeters further to the right from the previous hole. So let's say dimension, select that hole and that hole. Now we're going to specify it as 1.3 millimeters. Then, as our final dimension, it is specified that the holes on the right side of the board are 50.8 millimeters further from that hole. Let's add that dimension. We're still in the dimensioning tool. I'm going to say from the center of that one to the center of that one should be 50.8 millimeters. And what you will see is that the bottom hole moved along with the top hole because we told them they need to stay vertically aligned with one another. Now we can move on to the dimensions from the bottom to the top. Jumping back to our sketch, we see that the bottommost hole is 2.5 millimeters from the bottom of the board. Dimension tool, between that hole and that we want 2.5 millimeters. Then our next hole is the one on the right hand side, which is specified as being 5.1 millimeters above that previous hole. Go back in, dimension from that hole to that hole is 5.1 millimeters. Jumping back to our dimension, between those two holes is 27.9 millimeters. Dimension between there and there, 27.9 millimeters. And our last dimension is the topmost hole is 15.2 millimeters above that hole. Go back here, dimension, the distance between that hole and that hole is 15.2. millimeters. And there we have our drawn out mounting pins. So what we are also going to add to the sketch is the fact that we do not want our Arduino to be lying on the bottom of the board. So what we are going to add is we are going to add some standoffs that are also 3D printed into the base. These standoffs are going to be centered along exactly the same area as what our mounting pins are. So let's go ahead and use one of our tools that we have learned already to create that, and say we're going to do an offset of that, and we'll offset it by 1 millimeter. And we do the same thing for all of our pins. In this way, we have now created a slightly larger circle that is too large to go through the whole of the Arduino. In other words, once we've slid the Arduino down over the mounting pins, it will rest on those pillars. If we are done with this, you can go ahead and stop the sketch. And now we are going to extrude our mounting pins that we have put in place. So, first things first, grab the extrude tool. It will ask us to please select our profiles that we want to extrude, and we are going to use the inner circles for our mounting pins. After some experimentation, I have come to the conclusion that 17 millimeters is a good spacing for our mounting pins, a good length, and make sure that our operation is join. That means that the pins will be joined to the existing lid base of our enclosure. Hit OK, and then we should have our mounting pins. Now we want to extrude the standoffs as well, but our sketch has disappeared. We can easily go back, and that is a feature of Fusion 360. Once you have done something based on a sketch, it will automatically hide the sketch for you, assuming that you are finished with that sketch. But that is not the case here. We still want to do more extrusions based on that sketch, and you can. You simply reactivate that sketch. I am going to go back into my top view to make it simpler to select those circles. Hit extrude again and extrude the outer circles. Of our design. Go back into 3D view, and for these 4 millimeters is a good height to extrude them to. Once again, make sure that join is your active operation. This will ensure that the standoffs become part of the base and also become one solid object together with your mounting pins. Hit OK, and now we can go and disable that sketch. Fusion won't disable it for you again because you have manually made it visible now. So let's go and put it off, and then we should have some mounting pins in our design. And with some luck, we should have mounting pins that our Arduino will be able to fit over. As the next step, we will be adding the receptacles for the mounting pins into the lid. To do that, we are going to first hide our base and make our lid visible. And now I'm going to wrap around, and we're going to say we want to create these on this inside face of our lid. So as usual, create sketch, select the inside face of our lid, and there we now have our sketch ready to be started drawing. So now we could do this whole rigmarole again of finding out exactly where to lay out the holes, or we could use our projection trick. So what we will do is we will go and look at sketch 2, which is where we created our holes or our mounting pins, and then we are going to use project, shortcut key P, and we'll project the 4 mounting pins into our sketch. At this point we can say OK and hide sketch 2 again, and there is our mounting pins from the bottom. After we've done this, we are going to offset our holes just by a little bit, make sure that the pins slide into it easily. So once again, we'll use the offset tool, shortcut key O, say that, and I am going to make it 0.2 millimeters bigger. Same for this one, offset 0.2 millimeters, offset 0.2 millimeters, offset 0.2 millimeters, and then I'm going to go and turn this to a construction line, press X, and with our top one, remember these are the circles that we projected in from our previous sketch. And we have the holes. Now we also want to obviously have the hole be inside of something. So for this purpose, I'm going to re-enable sketch 2 again, and I'm going to say I want to project our standoffs diameter this sketch as well. Click OK, turn off sketch 2 again. There we now have the outlines of those ones, and if we go and have a look, we should be able to select faces of these halves of these circles, create our standoffs. So now we can say stop sketch, we can hit extrude E, shortcut key, and we can select our circles that we want to extrude. Build this whole thing to come into a bit of a 3D view, and say I want to extrude these for 7 millimeters. 7 millimeters was tested so that our mounting pins slide into it nicely, but there's still enough space at the top so that it doesn't interfere with any of the Arduino UNO's components. It's OK, and there we now have receptacles for our mounting pins. At this point in time, we can now go back into our 3D view and enable our base, and now we can use our sectional analysis trick again to do an analysis and see that our mounting pins are in fact there and that they do, as a matter of fact, connect into one another. I'm going to cancel this again because we won't be using it. Now, for us to be able to do any kind of assemblies, for instance, to say that this lid is interconnected with the base, or as our next step is going to be, importing an Arduino UNO into this design to check that it is working and also to facilitate the cutouts onto the side of this enclosure, we need to convert our bodies into components. So let's get started. To convert something into a component, you select your body, right click, and say create components from bodies. So this is our bottom, and you should see it turned it into component 1. And then I'm going, if you slow double click on it to open up the rename, I'm going to call this the base. Convert this one into a component, and I'm going to slow double click and call this the lid. And now we've got two separate components where we can turn off, and they are named nicely. This is also a good place to save. Since we have done a lot of work now, I am going to save mine simply as Arduino UNO case. Saving is also a requirement at this point in time because we are going to import another component into this design, and you cannot import components into designs that have not been saved yet. To import this design, go to your show data panel and you will see I already have an Arduino UNO model imported here. However, you might still need to do this. The Arduino UNO model is available in the gallery on Autodesk Fusion 360's gallery, and also available as a link in the description of this video. To upload it, you would download it to your computer and hit the upload button here. Select the file from your computer and it will upload it into your data panel. To insert this Arduino UNO into our existing design, click and drag and drop it into your design. It'll come up looking like this. It automatically drops the design at the origin. I like to, when doing assemblies, move my components a bit out of the way so that I can clearly see them separated. Let's hit OK after positioning it a bit away, and you should see you now have an Arduino UNO, and it should show in your browser list on the left here as well. At this point, I'm going to hide the data panel again to give us maximum workspace. As a next step, we are going to assemble this Arduino UNO into our enclosure. This can be done in many ways. You can also simply move it into the correct position and rotate it and do it that way, but Fusion 360 allows us to build assemblies that have joints specified. For this specific case, we are going to make a joint between our hole on our Arduino UNO and one of our mounting pins. As a start, for any kind of assembly, you should always have one grounded component. What is meant by grounded? Grounded means that it is restricted entirely in its movement. It cannot move up or down or left or right or rotate in any way. For this one, we will be doing that with the base of our enclosure. To ground it, simply right click on it, select ground. If it's been ground, you will also see that the icon next to it changes and shows a little pin on it to show that it has been pinned down in place. As a second step, to make it possible to move the Arduino UNO as one entire group when we do the assembly, we are also going to right click on the Arduino UNO and say rigid group. Rigid group basically means that all the components inside of this design will stay in exactly the same position relative to one another once we start moving it. It asks us if we want to continue, and say yes, and then it shows you there's 88 components inside of this Arduino UNO, and we are going to hit OK to turn it into one solid group. Turning it into a group does not mean you can't no longer work with the separate components. It just means that they move in relation to one another. As the next step, we will be adding the joint. This can get a little bit tricky, and we won't be spending an entire chapter on this, as this is only an introductory video, so please just follow along. Basically, under assemble, we will say joint, shortcut key J, to create a new joint. The first component you specify is the component that you want to move. In this case, want to move this component, and then we have to select a reference point that we want to line up with a reference point on the other component. In this case, I want to select this hole. Make sure it comes up with the cylinder when you hover over it. Hold the control button to snap in place the face that you want to select, and now you can move the mouse to select a specific point on that object. I want to select the bottom of this hole as my first component reference. Then I want to move over to my enclosure, and that hole is supposed to go on this mounting pin. So now I will just rotate this a bit to make it a little bit easier to work with. Zoom in here and say the point I want to align that one with is on this face. Hold control, and it gives me the ability to select the snap point, and I want the middle. You zoom out, you will see for currently it only moved the PC board. The reason for that is it only selects the component that you've selected. The Arduino UNO consists of multiple components, but for the preview of moving, it will only show us the PC board, since that is the component that we selected. Once the joint has been completed, all the components still visible over here will move back into place. We have created a rigid joint. What rigid means is once it's done, you will not be able to move this PC board at all anymore. Currently, this PC board is orientated the wrong way. So to create that, we'll grab it here on the rotate handle and simply rotate it by 90 degrees so that it is in the correct position. At this point, you can have a look, see that all of our mounting pins align neatly with our Arduino board. And if we hit OK now, all of the components will move into place, and we will have a fully assembled Arduino board in place on our assembly. Those eagle-eyed amongst you will have noticed that We have a slight problem with our design. If we rotate this around a bit, our components are sticking right through our enclosure. This is obviously not the kind of thing we want. We want those connectors to be visible through our enclosure. What we are going to do is we are going to create a sketch on this side based around the geometry of the connectors and use that to make holes in our enclosure. So let's get started with that. As step number one, we will specify that we want to create a sketch, and this sketch will be based on this face, the outside face of our enclosure. For the next part, I like to actually turn off that part and say now we can easily see the Arduino and with the components that we want to project coming through. Once again, we'll use our project tool, shortcut key P, and now we are going to say I want to project this face and this face of our connectors. Why did I not select all these outside parts of our USB connector? Well, if you were to rotate this around a little bit, you will see those are rounded filleted edges to make the connector look neat. They will not work very well for our 2D sketch, so that is why I have only selected flat face over here. I'm going to turn off our Arduino now so that we can work easily within our sketch. And now we will go and say I want to create an offset around this one, and in this particular case I want to create that offset to be about 1.2 millimeters big to make sure that our USB connector fits through there comfortably. Do the same side, offset, outside part, and for this one I'm going to make it a little bit smaller, 0.8 millimeters, to be about the same dimension than our USB connectors. Offset. Turning off the Arduino again, we can now go and say we want to put all of these lines to construction and everything inside of here to construction. This way I have two solid profiles to work with no holes on the inside. Next up, we're going to re-enable our base and our lid, since we want our cutout to be through both. Stop the sketch, hit extrude, shortcut key E, select the two cutout profiles, get back into a bit of a 3D view, and now cut through this enclosure. Note that the Arduino UNO is not visible. In other words, this cut command will only cut through visible components. It will not cut through any component which is not visible at the point in time that you cut. Also, I am going to make the cut minus 10 millimeters to make sure that even if we do make the wall on our enclosure a bit thicker, the hole will still be all the way through. If we hit OK, You should now see that you have two neat cutouts enclosure, and if we re-enable Arduino, our power connector and USB connector should be clearly accessible enclosure. I'm going to save again this point, as we have just completed a major part of the work. As our next step, we have now got an Arduino enclosure, but in my opinion, it's not very pretty. It's usable, but it's not very pretty. So, what we'll do next is some small work on the cosmetics and usability of our design. As a first step, I would like to chamfer the tips of our mounting pins. This will have the effect of making it easier to slide the Arduino UNO over it, and also for them to slide into our mounting receptacles at the top of the lid. This we will use the modify chamfer command. This allows us to select edges. In this case, I am going to select all four of the edges of our mounting pins and chamfer them by 0.4 millimeters. As you can see, this will have the effect of tapering them off, making them much simpler to slide into something. The next step, we also want to be able to access our Arduino UNO's connectors through the lid. So what we'll do is we'll activate our lid again and create a sketch on the top enclosure, top face of our lid. In this case, we need to know where the pins are of our Arduino UNO. So let's for now disable our lid, and then we use our old friend projection, shortcut key P, and in this case I'm not going to project the entire geometry. All that really interests us is this point up here, this point over here, over here, over here. This will give us 4 points, 2 points for each connector, to draw a rectangle. In this case, I'm going to put our lid back on. Click OK here for projection to be finished. And then we're going to use 2-point rectangle, shortcut key R. Select the first point, select the second point. Same for the bottom one. Hit escape, and we have our 2 rectangles. Now we could use these as a direct cutout, but probably we do not want to have holes that are exactly the same size than the pins that we're going to be putting through there. So let's use our alt friend offset, shortcut key O, to make these a little bit bigger once again. Now this is an interesting example with the offset command. Sometimes you will find that it will put, even though you're using a positive offset, it's going to the inside of your shape, and you would have to use a negative offset to go in the opposite direction. In this case, that is exactly what happened, and I'm going to make minus 0.6 millimeters. Use offset again. Same thing on this one, minus 0.6, and there we have our outlines now. Once again, geometry that just inside construction lines. Sure that not have any interference selecting the face, the profile to extrude. Have easily selectable profiles. I'm going to hit stop sketch and extrude. Select this profile, select that profile, 3D view, say I cut through this. Now, how far do we cut through it? Well, we could say give it a fixed distance, but in this case we are going to use another nice feature of Fusion, and that is to specify that we want to cut through this just until the inside face of the lid. To do that, we will need to turn off the base and the Arduino UNO so that we can see inside of our lid. Then we change the extent to object and we select inside face of our lid. And okay, and there will be a cutout made to our lid. All right, let's make all of our components visible again. If we now have a look at the top of the enclosure to see that the pins should be easily accessible via these cutouts. Save our design again at this point in time. As a final bit of work, I want to add some grills on the top of our lid here. I'll add a new sketch onto the top of our design, and from here on out I want to introduce a couple of new concepts. First of all, I want to create a nice arc curve over here that will hopefully be our curve that our grills run according to. And then second of all, we also need to be aware that we need to project in possibly the standoffs that we have created. Don't cut through our standoffs. What we'll do is we will project in our existing rectangle that we have here. We will project in our standoffs, and then that is all that we'll be projecting. Switch off all of our geometry, all of our objects, so that we can just focus on the geometry of what we want to do. And then we need to have a arc. So for the arc, we're going to use a 3-point arc. The arc between there. Oh, my mistake. I forgot select in cutouts at the bottom here. The lid, and we create our 3-point block. Sorry, I'm using command. We are looking for a spline. Select our first point, the middle point, our end point. Okay, and now let's escape. Now we can use these spline points. Our spline. Particular like that. And that is how you use the spline command. Then what we are also going to do is we are going to use something called a rectangular pattern in our sketch. This means is we are going to pattern this cutout that we have done here, pattern it that way. We want to have a certain amount of cutouts until what you think is sufficient. So this would be a cutout, that would be a cutout, that one, that one, that one. Hit OK, and now you should see you should have multiple of that same cutout going across here. What is good is with all of our geometry that we have projected in, and with our arc line that we have added in, we can now select these profiles as our cutouts. Do that, turn our lid back on, stop sketch, and we're going to use extrude. Now we can select these profiles that have been separately cut away from there and from our mounting pins. Drag it down to select cut as the operation, and now this time instead of telling it cut through, we are going to tell it to simply cut through all. Why through all? Well, our only object that is visible at the moment is our lid, and we want these cutouts to go all the way through our lid, so we might as well use the all functionality. Switch that, hit OK there, switch this back on. Now you should have a nice cutout on the top. To take this one step further, I also want to add some text. So we could go and hit create sketch and select this face to create it on, but for something simple like this we can immediately say sketch, just hit the face that we want to create the sketch on, text on, and start our text. My enclosure is going to say Arduino UNO. I am going to be using the Bauhaus font. I'm going to bold. At this point in time I can place where I want it to be. Okay, and now I have this text on the side of my Enclosure. I'm going to hit stop sketch. Once again, hit extrude. Select the profile of our text. Drag it in. Say I want it to be minus 0.5, 0.6 millimeters. Cut into there and some text cut out into the side of your enclosure. I'm going to save it before we continue. As our last and final step, we are going to add some color to our enclosure and also make a realistic rendering of it. To add some color, we go to modify appearance, or you could also use the shortcut key A, and you will be presented with a set of materials that can be applied to your components. For mine, I'm going to use plastic since we will be 3D printing this. Pick an opaque plastic, and I am going to go for a matte green lid and a matte red bottom base. And now we have applied some materials and we have some color in our design. Now, to render this in a realistic environment, we simply switch over to the render workspace, and you should immediately see it will be presented in a more 3D perspective type view. And now you can hit the in canvas render button. Given a bit of time, processing power, we will soon have a photorealistic version, or at least semi-photorealistic version of our Arduino that can be exported and shown. And there you have it, a photorealistic rendering of what your Arduino UNO case may look like once it has been 3D printed and assembled. That's it for this course. Please join us again for our second course, in which we will be designing a parametric wooden drawer displaying the power of using parameters to specify what our models should behave like. Thank you for watching.